Welcome all. This is our video project, and it's going to be over projectile motion. So, pretty much textbook definition is the predictable path traveled by an object that is influenced by certain factors. And my definition is simply the ability of an object to travel due to certain things. It's simple for the most part. But there are key factors that influence it, such as the initial launch velocity, the launch angle, the height, and the acceleration due to gravity. And so these projectile motion ideas they occur in everyday life whether we realize it or not. And so some examples is easily would be sports, basketball, golf, or anything that you're throwing something. So take this for example. Projectile motion, baby. And so how it applies to me, I'm a big basketball player. There's me, determined. It's a basketball. That's a hoop.
Artist over
So I got the height, distance needed to be traveled, and then you can think of this as an XY axis, Y axis, X axis, and so all these factors play a role into getting that ball into the hoop. And so without the right speed or angle, your ball is going to either go down here or it's going to hit the front of the rim. And so in all sports or everyday situations where projectile motion occurs, you need every single one of these factors in order to successfully get your object traveled.
So, I'm going to be talking about the 7 steps to figuring out the range of the projectile motion in horizontal. So, basically, the first one is you got to decompose the initial velocity into initial velocity in the vertical and in the horizontal. Basically, the next one is solving for time up by using equation 3, which is this horizontal one, equation 1, my bad, right there. Next one is it's solving for d up. This one by using equation 3. Next step 4, is solving d down by using d up plus the leftover space from that's lower than when the object started. And then step 5 is basically solving the whole entire the final velocity by using this equation 3 again. And then you also next one is solving for total time by using time up plus time down. Sorry about that. And then last step 7, is solving the whole entire projectile motion by using step 4. Also, I wanted to let you guys know the 3 things is height, which affects it by increasing time in air, the angle, which determines how much velocity is going to be in the vertical and in the horizontal, and then the initial velocity determines how long it's going to take to slow down the object.
And I'm just going to run you through some calculations that I did earlier. So as Chase was saying, you need to deconstruct the velocity initial, which is 6.5, into the vertical and horizontal. So you use that by doing SOHCAHTOA, so sine and cosine for each of these. And then after you have acquired that, you go and take the vertical component and then plug it into the first equation. So the velocity final for the first half of the parabola is going to be 0, as denoted here. So you're going to take 0 equals 5.889 minus acceleration, which is going to be negative, and to figure out time, so we get 0.6. And then we're going to find out how high, trying to find the apex of the specific object. So we're going to take all of those variables that we've figured out before, plug it in, and we get 38.17. Now we're going to figure out the velocity final at the final point. So we're going to take the initial height, add it to the height change, and that's going to be 110.17 meters. And then we already know all the other variables, and we're just trying to find out velocity final, so we get 46.5 meters per second. And then we want to figure out time for the second half of the parabola, so we plug that in with the other variables into equation 1, and we get 4.74. Then we add both of the little times together to get the big time, which is going to be 5.34. And then in order to figure out how far it traveled, we're going to take the time and multiply it by the horizontal aspect that we found at the beginning of this whole process, and we get 14.69 meters is the final distance. And that's kind of how you figure out how all the components of projectile motion. So,
Projectile motion, baby.
bam.